Hi, everybody. My name is Bertil. Welcome to my talk about event sourcing and behavior-driven development and the relationship between the two. I work for a consultants company called Hood Group. And first of all, let me tell you a few words about myself. So I started programming a while ago and worked in various industries like automotive, insurances, banks, software companies in several roles like programmer, tester, architect, also Scrum Master, but mostly a consultant. And you could say, I guess, that I'm a generalist. And that's why I'm so interested in looking at different fields and how they connect and how they fit together. And that also gave me the inspiration for this talk. So what really is the relationship between behavior-driven development, or BDD in short, and event sourcing, and how do these two methods fit together? So let's have a look at the agenda. First of all, I will provide an introduction to behavior-driven development. And behavior-driven development is largely based on examples. So we will look at several BDD examples to make it clear what behavior-driven development is all about. And then I will provide a short introduction to event sourcing, so that we are on the same page concerning that. And then at the end of the talk, I will connect the two. So how do they fit together, BDD and event sourcing? So without further ado, let's get started. What is behavior-driven development, or BDD in short, all about? So you don't have to take my words for it. Let's see how the inventor of BDD, Daniel Terhorst North, describes it. So behavior-driven development takes the position that you can turn an idea for a requirement into implemented, tested, production-ready code simply and effectively, as long as the requirement is specific enough that everyone knows what's going on. So what's the key takeaway here? You want to come to a common understanding about the requirements, and you come to a common understanding because you have a specific shared understanding of the requirement. And once you have that, you can go on with that understanding and use it to implement your solution based on that understanding. And Mr. Terhorst North goes on and says, to do this, we need a way to describe the requirement such that everyone, the business folks, the analyst, the developer, and the tester, have a common understanding of the scope of the work. So bring people together. They need to have a conversation, talk about the requirements, then specify the details, write them down. And once everybody has a shared understanding, you can use this documentation of the behavior to drive your development. So much for the theory. Now let's have a look at how this could look like in practice. So this is an example process of how this could look like in practice. So at the very left, we start with a user story. Think of an e-commerce application with a user story. As a supermarket customer, I want to collect items in a cart so that I can buy them at once later. So probably it doesn't matter if you're in a brick and mortar supermarket or in an e-commerce shop. That's always your main story, so to say. So in terms of BDD, people would meet, business people, domain experts, developers would meet Sometimes there's also talk about the three amigos. So, for example, the product owner, a programmer, and a tester at least. They meet, and then this story that you see at the left is kind of vague, right? There's a lot of detail missing. And that's intentional because that then leads to a conversation that these people have. And then they document the details of that conversation, for example, as a so-called Gherkin scenario that you see in the middle. So given that the shopping cart contains these or that items, when I put these or that items into the shopping cart, then the shopping cart will contain these or that items. The total, the sum of all items is this or that. We will come back to that later. I will show some examples. So what you should keep in mind is that in these scenarios, you describe the details of the requirements. And then once you got these details, then you can go into implementation and write an automated test for that scenario. There are dedicated tools like Cucumber or JBehave or RSpec for this that read in these examples as text files, but you can also use your favorite unit testing framework like XUnit, JUnit, for example. And if you do that, if you write these tests yourself, then you should take care of using the same terms that you used in the scenarios, right? As you see at the right side of the screen. Because then maybe with a little bit of training, even a business person could read that and understand the intent behind this test in the code. So you write these tests first before you go into the implementation. So it's like taking or doing test-driven development, but on the whole application level. And these tests, of course, they fail at first. And then as a developer, you create the implementation that makes the test pass. And then you can be quite confident that you implemented the requirement in a way that matches that shared understanding. All right, so that's one typical process that you follow if you do BDD. Let's have a look at a few examples of these Gherkin scenarios that I've showed on this slide so that this becomes a little bit clearer again. So here's the user story again. As a supermarket customer, I want to collect items in a cart so that I can buy them at once later. A very simple scenario would be that given that the cart contains no item, when I put a cucumber for a certain price into the cart, then the cart contains one cucumber, obviously, and the total is the price of the cucumber. So this is kind of like a trivial starting scenario. If the cart is empty at first and you put something in, then of course that's in the cart. Then the next scenario could be, okay, the cart already contains a certain item. When I put a different item into it, then both items are contained in the cart and the total is the sum of the items. So that would be a second example, also, I would guess, quite simple. Now let's have a look at a different, a little bit more complicated scenario. So given that the cart again contains a certain item and there's a discount on that item, let's say 20%. And then maybe even as a customer, I put another item in it, then these two items need to be in the cart and the total needs to be calculated correctly. So the 20% discount are only applied to the grapefruit in that example, but not on the cucumber. And now we're entering the area where these kinds of examples become more interesting, because this is the stuff that as a developer, you really want to talk with business about, right? What kinds of discounts are there? For example, there could also be discounts if you put certain combinations of items into the cart, then there will be a discount and so on. And that's the kind of stuff that you want to find out in detail and create more examples of. All right, so these are some examples of these Gherkins scenarios that you then later on use to as a basis for the automated test. This given when then template has a certain structure. This is a general pattern that it follows. And you should keep this in mind for later on, because we will come back to this when we come to the event sourcing part. So there's given, there's when, and there's then. And given is the state of the system before the action takes place. You could also say the precondition. What state needs the system to be in before the user action takes place? And then the when is the user action. Remember, for example, the customer puts an item in the cart, and the then part is then the state of the system after the action has been performed. And the great thing about this is that this actually mirrors the structure that you have in example-based tests, because in example-based tests, you have a similar structure that is called arrange, act, and assert. Arrange means put the system in a certain state. Act means trigger the behavior, for example, call a method or a function. And assert means check the state of the system under test afterwards. So this mirrors this given when then, and that's why this pattern is so good for testing, because you can basically directly in a straightforward way derive your test cases from this. All right, so that's it concerning a very short introduction to behavior-driven development. Now let's have a look at our second topic of the talk, event sourcing. So what is event sourcing all about? Again, there's a definition, this time by Martin Fowler. Martin Fowler, probably all of you or most of you know him. He's a very well-known software developer, I would say. And also he has a so-called Blicky, where he writes many articles on patterns of software developments and terminology and so on. And he defines event sourcing as event sourcing ensures that all changes to application state are stored as a sequence of events. So that means, I would say in my words, event sourcing is a persistence strategy, right? Instead of storing the application state just as is, you store all changes, each and every change to the application state as an event, right? And the difference is you don't just store the latest state of, say, the shopping cart. You store all changes to the shopping cart. Every time an item is added, every time an item is removed, you store this as an event. Now, the question, of course, is why would you do it? What is event sourcing good for? There are several reasons why you might want to do this. One reason is if you store all events, so all changes to application state, you can use this for auditing purposes, right? If you want to look back, okay, which business relevant events happened on, let's say, February the 2nd, then you just look into your event log and you see, okay, this is what happened. And of course, you can use this as an audit trail, because the events, once they are recorded, they are not modified. They are stored as is, and you keep that event log and you just add to it. One thing that's very interesting about event sourcing is also that you can use it to analyze or rebuild previous system states for business analysis. So you have this event log that starts from the beginning or from a certain snapshot of a state, and then you can replay all the events that happened since then. So perform all the state changes again up to a certain point in time. So I can ask the system, what was your state, let's say 2 weeks ago? And then the system will be able to recreate the state at that point in time. And of course, this can be interesting, for example, to analyze user behavior in that way. Also, one more use case is you might want to reproduce prior system states for incident exploration. So let's say something goes wrong in your business, and then you want to debug it, and event sourcing will allow you to turn back time to the point in time when the incident happened, and then step through the changes event by event and see what happened to the state. So these are all reasons why you might want to use event sourcing. Now, we have a kind of a trivial example here with a shopping cart. So you might ask yourself, well, for a shopping cart, why would I do event sourcing for something simple like a shopping cart? But even then, your business might want to know why people remove items from the cart as well, right? If you just store the current state of the cart at the point in time of checkout, for example, you lose the information which items people removed, and that could be interesting. Maybe they are, for example, too expensive or something like that, or you changed the price, they became too expensive, and then people started removing these items from their carts. And that's the kind of stuff you find out if you do event sourcing. All right, that's it for the introduction to event sourcing. Now, how does event sourcing work in general? And we're specifically looking at command handling now. So there are basically 2 steps. The first step is the decision needs to be made. So an entity needs to decide whether it accepts a command and produces events or not. And once the events are produced, they can be persisted and applied to the entity to change the state. So the entity receives a command like put item in shopping cart that reflects the user intent, and then it decides, for example, okay, shopping cart is empty, I will put it into the shopping cart, and in this case, it will produce one or several events that reflect the fact and contain all the details of the item that needs to be added. On the other hand, it could also be in step 1 that the entity receives the command for adding an item to the shopping cart, but the shopping cart is quote unquote full, right? There's a maximum number of items in the cart, and then the entity will reject the command and no events will be produced by the entity and nothing will be persisted. But let's say the entity accepts the command and then produces the events to be persisted and applied. At that point in time, no change to state has happened so far. Only in the next step, these events are then applied to the entity, and that basically you call a method then on the entity, and then the entity changes its state, or a new state is produced for the entity, and the entity has the new state. And because all the facts are stored in the events and all of that is recorded in event log or event store, they can be applied later on as well, right? Before receiving a command, you can reapply, starting from a certain point in the past, all the events that happened so far, and by that reconstruct the entity state, and then handle the command as shown above. And you can also do all the other use cases that I've shown before concerning reproducing prior states by reapplying events, as you see in step 2. So here's an example of what that could look like. You would have the put item into cart command with certain information about the item to put in and the amount. And you had, let's say you have the empty cart with a certain ID, and that would lead to an item put into cart event that is then stored in the event store as well. And in the second step, it's applied to the cart. And after that, at the bottom right, the cart contains the item. So this would be just one run through. So it starts with the command and it ends with an updated state of the entity. All right. So that's it for the introduction to BDD and to event sourcing. And now the interesting part, how do the two fit together? For that, remember that the template was given state of the system before the user action occurs, when the user action occurs, then the state of the system after the action occurs. And now you can think about, okay, how do we specify the state of the system before the user action occurs? What is the user action in event sourcing, and how do we basically map this onto event sourcing and an event source system? And actually this is really straightforward. So given is the state before, and how do you create the state in event sourcing? You apply all the persisted events so far. That way you reconstruct the state. Then when is the user action? This is exactly what we've seen on that slide. It's the entity handles the command, right? It receives the command, decides, do I accept it, do I reject it, and produces the events. And then is the state after the command has been applied. And we can find that out as well, because that's the new state of the entity then. As an alternative, and then we could also say, okay, we just check the events that have been produced, but what I'm showing here is basically going all the way from the state before to the new state. So let's have a look at our example with the shopping cart again. So given that the system applied item put into cart, this event to the cart, so this is just one event happened, let's say item put into cart, so one element. And when the cart then handles the put item into cart command, then the cart contains two items and the total is. So that's the general structure, and that's the mapping that you basically can apply to any kind of event source system to use BDD in that context. All right, so that's already it for my little talk. So what are the key takeaways? BDD is an approach to create a common language between business and development. Everybody should receive a common understanding and use the same terminology. Sometimes this is also called an ubiquitous language. So it bridges the gap between business and IT and enables test-driven development on a whole system level. Event sourcing, on the other hand, can be helpful for auditing purposes or to analyze or rebuild previous system states for business analysis or reproduce prior system states for incident exploration. And the two really fit very nicely together. And if you want to use BDD and you think that's a good approach to drive your system development, you can really use it in a very straightforward way in your event-sourced systems. If you want to try this out yourself, I also created a small library on GitHub, and there you can both build an event-sourced application using it in a relatively, I hope, simple way. And you can try out BDD style testing. All of that is covered in the so-called Being library that I created. It's written in Java. And if you have any questions concerning this topic or want to get in contact with me or have a chat or whatever, then you can find me on Twitter and on LinkedIn under my real name, Bertil Muth, and I look forward to hearing from you. And that's it from my talk, and I hope you enjoy the rest of the summit.